Foundations of amateur radio. Have you ever had your radio on listening around, say on 40 meters, and heard the following? CQ 40 meters, this is VK6FLAB calling CQ 40 meters calling CQ. Apart from the fact that the station calling seems pretty desperate for a contact, you're tuned to 40 meters. Why on earth would you actually mention that? What's the point of telling me what band you're calling on when clearly I'm hearing you on that band? The answer to this question is in harmonics. At the heart of every radio is an oscillator, set to some or other frequency that forms the basis of all that happens around it. In order to arrive at different frequencies, we add and subtract double and half frequencies, all combining to arrive at the various frequencies and bands we use. I'll use some fictitious numbers here to give you an idea of what's happening. Imagine that you have a 3.5 MHz oscillator. With it, you can double it to 7 MHz, double that to 14 MHz, double it again to 28 MHz. That's 80 meters, 40 meters, 20 meters, and 10 meters just by using doubling. You could use the same oscillator and a doubler with a frequency tripler to get 21 MHz and so on. A side effect of doubling and tripling frequencies is that this process isn't perfect or linear. This in turn means that some of those imperfections also get doubled and tripled. These imperfections are called spurious emissions, and we reduce them as much as possible. In fact, it's required by legislation to be below a certain level below the wanted emission. As technology improves, these spurious emissions standards evolve. The US FCC, as an example, says that for radios built before January 1st, 1978, they're exempt. Radios until 2003 must be 30 dB below the wanted emission, and current radios must be 43 dB below. What this means is that, in effect, your radio is transmitting on multiple frequencies at the same time, but filtering prevents most of this from coming out. Now imagine that you have a series of dipoles connected to your radio, one for 160 meters, one for 80 meters, one for 40, one for 10, etc. Imagine that your radio was built before January 1st, 1978, and you're calling CQ. The harmonics are being generated, and because you've got an antenna connected that can transmit those harmonics, they go out into the wide blue world outside. It's entirely possible that someone listening on 20 meters, 15 meters, or 10 meters is hearing you calling on 40 meters through your spurious emissions at some or other harmonic. So next time you hear a station calling CQ 40 meters, they're either rusted-on die-hard amateurs on a modern radio, or they're using a so-called boat anchor having fun on air. Either way, it's a great idea to say hello while you have the opportunity. Perhaps even use the experience as an excuse to learn more about their station, or even check out their harmonics and let them know if you can hear them. Propagation be damned. I'm Ono, VK6FLAB.